Morning, everyone. I'd just like to introduce to you the part of the new Xplained development system that Atmel's launching today. This is we call the Sensors Xplained development system, and this is looking at some work Atmel's been doing, trying to make interfacing with different sensor systems, gyroscopes, compasses, acceleration sensors, much easier to do, and trying to accelerate the development curve for everybody working on the sensor kits. So introduce these. The system we're showing with you is part of the Xplained development platform. The Xplained boards are the processor boards up here at the top. These are a series of microcontroller processor boards. The boards cover all of the AVR microcontroller family, all the way up from the small 8-bit tiny devices through the UC3 32-bit processor families. And these boards all have the same form factor, so they're the same size, they have the same connectivity and the same headers on. So it makes it very easy either for Atmel to provide different top boards and top modules for these, which will work across any of those microcontrollers. But also if you're doing your own developments and you're wanting to do some prototyping and try some different systems out, it makes it very easy for you to go put boards together and then be able to move them between different microcontrollers if you're not sure which family you need or whether you need 8 or a 32-bit performance. In addition to that, we're providing a number of top boards highlighting different combinations of sensor systems, and we're also providing a software solution working with the different sensor companies to incorporate the necessary software, drivers and calibration routines into the Studio 5 development environment to make it really easy to hook up and communicate with these sensors. So the initial boards that we're supporting on the Xplained family, there's 4 of them which are available as of today. And if you keep a watch on the website over the coming months, you'll see more of these becoming available over the next couple of months. So the top 2 here are part of the 32-bit family, the UC3L, which is the low power, particularly optimized for portable and battery power applications, and the UC3A, which is kind of the high-end, high-performance end of the UC3 family, and you'll see additional boards coming out. We have one of the X-Mega family, which is the high-end 8-bit family. And we have a board here from the Mega family, which is kind of the mid-range 8-bit family device. So this is the starting set of boards we have, but over the coming months you'll see a lot more of these becoming available as well. Atmel doesn't produce a lot of the sensors and a lot of the gyroscopes and compasses directly, but what we have done is we've gone out and partnered with the leading suppliers of all of these different sensors and worked to put a system solution together for you to really help accelerate the use of these sensors. So on the launch of these products, we have 6 companies that we're working with today. We have AKM and Honeywell, who we're working with on electronic compass or magnetometer solutions. We're working with Bosch and Kyonix on acceleration sensors and gyros and pressure sensors, and InvenSense, particularly on the highly integrated gyroscopes, including the basic 3-axis gyroscopes that they've had in the market for some time, but also some of the newer parts they have where there's combination gyroscope and accelerometer multi-sensor devices as well, so those will also be supported. And we're working with Osram looking at some of the optical sensors, so optical sensors both in terms of ambient light sensing, but also coupled with IR emitters for doing proximity detection, being able to recognize gestures and proximities over the top of the sensors as well. The different top boards are developed to try and showcase different combinations of these sensors. So we're not going to be able to have a board that has every combination, but what we've tried to do is pick popular combinations of board. So this is what we call the inertial 1 board, which has a 9-degree of freedom solution. This is combining acceleration and gyroscope and compass information. So you can get a really good 3-dimensional positioning system. You can track motion in 3D for if you're trying to do kind of an air mouse type application. You can also use these for doing motion sensing or monitoring. We've seen these used in emergency and life-saving kind of equipment if somebody falls over or doesn't move. In medical equipment, I've seen these built into the handles of your golf club to analyze your swing. I'm not sure if that's a good idea or not. But these really are aimed at being able to track these three-dimensional motion type applications. And the combination of sensors really allows you to link in software, link the sensors together and actually get better information than each sensor individually provides. So it allows you to use the sensors in combination very easily. At launch today, we're actually making available 3 different sensor boards, and just like on the processor boards, if you keep a watch on the website over the coming months, you'll see more of these become available throughout the summer. But as of today, we're launching with 3 initial boards. There's 2 different inertial sensing boards, we call inertial 1 and 2. These have the same basic functionality. They both provide the same 9-axis field of motion sensing, but they work with different combinations of sensors. So we have InvenSense, Bosch, and AKM on the inertial 1 sensor, and we have a different InvenSense, Gyro, Kionics, and Honeywell magnetometers on the second sensor. The sensors all tend to be optimized for different uses and different fields of use. So for example, you have a Hall effect sensor for AKM doing the compass, and Honeywell uses a GMR type sensor for doing the compass function. So depending on your application, one of those may be more suitable for you for the other. So we're trying to provide examples of different combinations of the sensors. And the third board here is a pressure sensor board. This is a barometric or atmospheric pressure sensor system. So obviously this has a lot of applications, sensing atmospheric pressure and weather stations and things. But the other thing to think about on these sensors is they're incredibly sensitive. The pressure sensor can actually detect an altitude change of around 10 to 12 inches. Just by the pressure sensor change alone. So this can allow you to detect altitude information of a person moving. So one of the areas these get used actually is in combination with GPS. GPS can tell you where you are, but not very accurately how high you are. So if you're in a multi-story building, for example, it can't tell you what floor you're on. A combination with a pressure sensor actually gives you that ability. You can easily detect what floor somebody is on using the combination of the sensor data. In addition to the hardware solutions, to try and make interfacing with these products easier, we've worked with the sensor companies to build the interface and calibration software into the Studio 5 development environment. So rather than getting and having to access the raw sensor data from each of the sensors and register level program the sensors to get the information out, we've provided a function level interface, an API level interface, so you can issue a command to get direction from your compass, and it returns you a calibrated compass heading instead of reading the 3 individual magnetic field strengths that you get from the sensor directly. So it makes it much easier to be able to work with these sensors at the application level and very quickly move on to your application development. The second advantage of this approach is by putting the interface to these devices through a standard API and linking this in with our studio development environment. What it allows you to do now is to be able to move between different processors and different sensor combinations much more easily. So actually on the demo stand over and around the corner here, we have a demonstration set up with just a very simple application, which is outputting the sensor data and displaying it like an oscilloscope graph on the screen. But we can take exactly that same application and change out one of the sensor boards, put in a different sensor board, rebuild the application. It takes about 60 seconds and you're running with 3 completely different sensors, because all of the application is interfacing through these defined APIs. So it makes it very easy to be flexible in terms of when you're building your systems using different combinations of sensors depending on your application, but also to move between different Atmel processors. So you may have an application for a low-end system developed on an 8-bit microcontroller. It makes it very easy now to be able to port that up to a higher-end application running on a 32-bit controller, which has a lot of extra overhead you might want to build into the system. So it allows you a lot of flexibility and portability between those systems. The driver software is available as part of the new studio development environment from Atmel. So this is the new Studio 5 system. This was announced a couple of months ago now in beta form and will shortly be released in full format, in a full release format. And the drivers are actually part of the studio environment. So when you download the Studio 5 update, you actually get access to the sensor drivers for these different boards as part of that environment. So those are all provided in there. So just to kind of summarize a very brief introduction here to what we're doing on the sensors side, the goal here is to try and make it easy for people to take advantage of the growth and the huge improvements in the performance of these sensors. I remember just a couple of years ago, some of these 9-degree sensor boards cost a couple of $1,000s each. It's only 5 or 6 years ago these things were really expensive. So these boards now are aimed to be very low cost. The boards themselves sell for about $55. In volume production, obviously a lot lower cost than that. But these really now do open up a whole range of applications to be able to use this kind of motion sensing interface, to be able to get environmental information into your systems, either using it for tracking how people are moving, or monitoring equipment, or picking up vibrations on fans and motors to detect early life, sporting equipment, medical equipment. It's a whole range of different applications. And the goal of this system is to try and help accelerate the development, try and make it easy to interface with the devices, and make it very easy for you guys to be able to work and develop your own systems quickly. So thank you for the time.